All right. Let's just begin. My name is Jelmer Knijvers. I'll be the moderator in this session. Arno will be presenting some cool stuff about blockchain. And before he starts, I want to introduce Arno for a bit and explain the house rules within this session. Let's start with introduction. Arno Laeven, thank you for being here. This is already our third virtual Interconnect Day session, and it's the first time we talk about blockchain and how this can affect our lives. So it will be very interesting to hear what you're going to say. Arno, before so first of all, a short background. As I understood, Arno is already 6 years active in the blockchain environment. Started at Philips and also participated in streams within so it's right here, KLM, Bosch, Energy Web Foundation, and the European Commission. Maybe you'll also get back to that in this presentation. But what I really found interesting is what he said on his LinkedIn page, what he is doing, and it really sums up within one sentence, and it's working towards a more resilient, secure, privacy-centric, and democratic digital society. Well, if that ain't what we all want, then I don't know what is. So I'm really interested to hear what you have to say, and also what blockchain will do in decentralizing and helping us finding new ways into a more environmental friendly world. So that's for me the introduction of Arno. There is an opportunity to already ask Arno questions during his presentation. That is within the chat. You can leave your questions there. I'll interrupt his presentation during and ask these questions. You won't have the ability to ask them yourself, but I'll do that for you. We do have a hard stop at 4 o'clock. So let's leave it with this, and I'll leave the space to Arno. Take it away.
Thank you very much, Jelmer. I hope everyone can hear me well and that you can see my screen, which should say Dutch Blockchain Coalition and not much more than that, because otherwise you're looking at my notes and you already know what I'm going to say. If no one is flagging this, then hopefully you see the right screen. So thank you very much. I can't see you. I can't see your questions, but Jelmer will help me with this. So please go ahead and type your questions into the chat box, and I will be able to answer them. As Jelmer said, I am active in the blockchain space already for 6 years. I started out when I was heading up the IT innovation department in Philips, and after Philips, I helped KLM, Bosch, Shell, Energy Web Foundation, and now the Dutch Blockchain Coalition when it comes to strategy and leading blockchain projects. So the Dutch Blockchain Coalition is, as it says, a coalition of organizations, both private and public organizations, from government, ministries, but also the large corporates in the Netherlands, with the aim to actually, lift up the topic of blockchain onto a strategic level, and we do that within a couple of themes. If you want to know more, just go to our website on DutchBlockchainCoalition.org, and you will find much more information there. For now, I would like to talk about the topic and really dive into it. This is a talk about blockchain, but we really need to see this in a bigger context. So blockchain technology has been called often a solution looking for a problem, but I would rather say blockchain enables is a way to enable solving problems that we only start realizing that we have. And I would like to highlight 3 of these problems, which we don't or just start to realize that we have, where blockchain can play a role. First of all, there's a growing worry about big tech and the economic and societal dependencies on the winner-take-all platforms. And you see a couple of them here on the left in this picture on the screen. Especially the European Commission is trying to find a way to regulate large tech. I think, to be honest, that for a part that that is naive to try to regulate that to the degree that we would like. But I will get back to that. The second problem that I would like to highlight where blockchain might play a role is that we are facing problems that go far beyond individual organizations, industries, and even countries. To name one, climate change. If, for instance, we want to track the CO2 footprint of products or people, we better start thinking how we want such a system to actually operate with the right incentives, transparency, but also free from political or commercial arbitrariness. We really need, for such a thing to work, a system which we can rely on. And the third area that I wanted to highlight is, many of you have heard of the term Industry 4.0. I'm pretty sure we are moving towards a machine-to-machine economy, and we need other mechanisms for transactions between machines than we have between people. So the question is, how can we organize for trust between machines? How can we identify a machine? How can a machine be economically autonomous? And those are the 3 problem areas where I believe, and where the Dutch Blockchain Coalition believes, that blockchain can play a minor but important role and create a better digital society, as Jelmer already said. And to understand how, we first need to take a step back and understand how we ended up where we are. Whether we like it or not, we live in a complex cyber-physical world. Our day-to-day decisions are increasingly driven by data and algorithms. And the picture you see here on the screen is actually the German artist Simon Weckert. Last year in 2020, he took a small cart, which you see him pulling behind him, and stuffed it with 99 smartphones. And all the phones, they ran Google Maps in the background. And Simon started walking through Berlin. And the data generated by the 99 smartphones were interpreted as slow-moving traffic. So the streets where he walked turned red on Google Maps, and cars took a detour. So with this walk through the streets of Berlin and the data generated, he changed the physical reality. So data plus algorithm, something digital, changes the physical reality. And we know this from every day. And this is a funny example, right? So what happens? But there are also more serious matters where the consequences are actually more far-reaching. So most of you will know that the Leave campaign in Britain used data and algorithms to, first of all, find a group of voters that no one actually cared about or thought about or knew about. And they found a way to draw them to the polls. And B, they made really clever use of social media to create sympathy for the Leave argument. And in 2016, Britain voted, as we know, against all expectations for Brexit. And the consequences of the decision are grave, and not only affect the UK, but also us here in mainland Europe. And there are many examples of the often unintended consequences of the digital revolution. So we really should ask ourselves as a society how to deal with this. And as Dutch Blockchain Coalition, we don't think regulation of big tech will solve this, as I mentioned earlier. We really need to look at the power balance in the digital society. And paradoxically, maybe, the solution is more instead of less technology. And again, let me explain why I think that. So with digitalization, we made real things virtual or digital, like shopping, working, education, and even love. But how do we know that what we see and experience in a digital environment is real? So the famous saying is, and this was a cartoon in the New Yorker in 1995, I believe, on the internet, nobody knows you're a dog. Or the more modern version would be, if you look at this picture, nobody knew that Bill is not really a man looking for a woman to cook him supper on Tinder. So digital assets, which we could call Bill as well, lack a way to prove that they are the original thing. Digital assets don't have a past, they don't have a present and future of themselves, and can be copied endlessly. So what we did is we solved this problem by using trusted third parties for almost anything we do online. Banking, of course, which is maybe a major example here, but also logging into any service that we use, and even visiting a website itself where there's a certificate underlying the website proving that it's the right website, or that is the website can be trusted. And that goes back to root certificates, and there's always a trusted third party that issues these certificates. So we very much rely on these trusted third parties. And that comes at a high cost. Very direct cost, like transaction cost, right? So every time that we do a transfer, and believe me, if you make international money transfers, for example, that is quite costly. So there is a transaction cost related to third parties that we use. But there are also economical and societal costs that we encounter, like security, right? If all data is within one big silo, then it makes it really interesting for anyone to snoop around in that data. And we all hear more and more about data breaches every day. And that touches upon the part of privacy. Because if your data is leaked outside, then someone can steal your identity or what have you. But also the data that this trusted third party can actually see from you. Again, intended or unintended. I think that in a lot of cases it's really not intended, but it can still be very harmful. It also creates a one-sided dependency, and especially in the case of monopolies, which we see more and more because the platform model is a winner-takes-all model. So we are very much dependent on these platforms for everything that we do. And that is, let's say, a more societal problem if we lack transparency and there is no control from our side and no autonomy from our side, but we still depend on these platforms. The question is whether that is something that we really want as a society. These problems is exactly what blockchain solves. So in 2008, most of you will probably have heard of this, Satoshi Nakamoto, a pseudonym for a person or a group of people, published a white paper called Bitcoin Peer-to-Peer Electronic Cash System. And the idea was really simple. What if we devised a system which does not need a third party to mediate in online financial transactions, or actually in any transaction that you do online? And this was done by combining proven technologies like strong encryption, distributed computing, and consensus algorithms. So here's a bit of a schematic view of how blockchain works. And if you want to go into more detail, please go to this site, which has really some great explainers, cryptographics.info. But the schematic view is a bit like this. A transaction between two parties, which can be individuals, organizations, or machines, is signed cryptographically. And that's already an important step, because you can never deny afterwards that you did not want to do the transaction, as you had to actively sign it. And you are the only one who holds the private key. So the cryptography makes use of a private and public key, the private key to do so. And think of dispute resolution as an immediate benefit of this, right? So you cannot deny that you wanted to do this transaction. The transaction is then broadcast to the network and added to a block. And to chain the new block to the previous one, a difficult mathematical puzzle needs to be solved. We also know that as mining. The one who is first wins, and their block is added to the chain, and they get rewarded. This solving of this difficult mathematical puzzle is very specific for Bitcoin and Ethereum. There are other blockchains that use different algorithms or protocols for solving this problem, for reaching this consensus, and that don't use nearly as much as, or only a fraction of the energy that is actually being used by Bitcoin, because I'm sure that most of you have heard about the energy consumption of Bitcoin, which is huge. The transaction is, the nodes accept the signed block, so this is the miner that won signs the block, and the nodes in the network accept the signed block, and they start all over again. And in Bitcoin, for instance, they do that every 10 minutes. Other ledgers can do it within seconds or faster. The essence is this: transactions are recorded in a ledger that shows the correct order of the transactions without the need for a trusted third party to enter the transaction into the ledger or to maintain it. So by securing every update in this immutable shared ledger, you don't need a third party. And that's quite a thing, right? Because with that, we have established a technology in which we can say something about digital assets themselves. And the interesting thing is that with the launch of the Ethereum blockchain in 2015, this not only works for assets, but also for code. Through a mechanism called smart contracts, we can also add rules to the behavior of the assets. And these rules are secured on a blockchain as well, and can only be executed as they were meant. And it can be verified that the execution actually went as it, or took place as it should. And the most simple example of this is an escrow model, where a payment will only take place after a certain condition has been met. So now you can not only know what the algorithm does, but also whether it was executed as planned and that it has not been tampered with. In other words, we open up the black box that we have been working with until now. I thought to put in a little bit of a tech stack here, since a very simplified version, since I know most of you have a technology background. Many of you are in layer 0, and layer 0 is very important. So the hardware network. First of all, blockchains function over IP, and there's no additional wiring needed or anything. For the mining or validation of transactions, however, an ASIC is used. Although it really depends on the blockchain. Sometimes the validation of transactions can also be done in the cloud by running a node in the cloud. But it is important for the network to be as decentralized as possible, so that each node can fail independently. What that means is that you don't want all nodes, for instance, running in the same cloud. There needs to be a certain randomness towards, let's say, the software version used, the cloud used, even the geography used. So the more widespread it is and the more nodes you have in a network, the more secure the network is. And that's, I think, important to remember. So that is explaining what blockchain is. And let me stop here for a brief moment to see if there are any questions. And what I will do before I turn to some examples.
Currently, there are no questions in the chat, so let's have a brief moment for people to give their questions. But I already have one. You started off with also explaining how blockchain can benefit also the environment, right? And make the world a bit better. But if you look at the most well-known and public available blockchain, it's Bitcoin, and it already uses way more than the total of Netherlands on energy usage. What's your take then on how can those two be combined? If the one application of blockchain already uses that much energy?
Yeah, exactly. As I mentioned earlier, this is a very important topic, and actually was also brought up by Elon Musk. So first, Elon Musk, as we say, pumped the price of Bitcoin tremendously by saying that Tesla is going to accept Bitcoin for payments. And then the price dumped when he said, well, actually, we're not going to use it because it's so polluting. So it is quite a topic. It is true that a lot of energy is used, you could say wasted, but you could also say used to actually secure the network. So it is on purpose that so much energy is used. A counter question could also be how much energy is used to secure other transaction systems, financial systems, fiat currencies, etc. But that's a little bit of a difficult one because, how are you going to compare that? So a fiat currency like the euro cannot, or the dollar, cannot operate without government, without an army, without what have you. So that uses a lot of energy as well. But I don't want to compare Bitcoin to a euro or dollar yet. I think what's more important, especially for us to remember, is that there are many other blockchains and other ways of what we call consensus algorithms. So Bitcoin and Ethereum mainnet now use proof of work. That is very energy intense, but most blockchains out there that operate outside these two are what we call either proof of authority or proof of stake networks. And they work in a completely different way. So they don't use the kind of energy that is used by Bitcoin or by Ethereum, by far not. So it's not even comparable. So there are already alternatives, but it's always a trade-off between, let's say, the total security of the system and the purpose of a specific blockchain.
Yeah, because what I understood, and correct me if I'm wrong, is that so those alternatives, right? Not by work, but by state or authority. You basically need a central authorization again, instead of what caused the whole blockchain activities is pure decentralization, right?
Yeah, so that is actually not correct. So to give an example of the proof of authority, I worked myself on the energy web chain, and the energy web chain is run actually by, so there are more than 100 energy companies worldwide that are a member of that. So Shell, Engie, what have you, larger TEPCO, large energy companies. And about 40 or 50 of them now run a node. So each of them runs a node, and there's no central authority. Each transaction is added because randomly each node adds the transactions. So there's a randomness in which one of these 40, 50 nodes is actually adding the transaction. And they have an incentive to do so in an honest way because, as it says, proof of authority, the authority is here at stake. So none of these companies actually wants to put their authority at stake if they would do wrong, because that would be immediately visible in the system. So that's why you can create it in a different way.
Okay, thank you. There's still no question. Let's move on with your presentation.
Yeah. And let's move to some examples here. And I picked the ones where I think that are actually where blockchain really plays a role. So one of the most evolved areas, I would say, in blockchain, besides finance and trade, is supply chain management. And the issue in supply chain is actually very clear. So there's a lack of end-to-end visibility on the product, which leads to disputes, hiccups, no real traceability, and added cost. So blockchain is not going to prevent a ship from getting stuck in the Suez Channel, but it can do other things. Centering the data around the product enables, for instance, a kind of passport to which information is added each and every step in the supply chain. And that also opens up the possibility to create other incentives and processes in ensuring that products move forward in the supply chain in the way that is intended by the whole supply chain. For instance, you could say, I wanted to move forward against the lowest possible CO2 footprint, right? How do you know if you do not have the data and not the real-time visibility on what actually happens to the product and so on along the way, what materials are used, and so on and so on. So the areas where this is already implemented, so yes, we do have working blockchain solutions, question I get a lot. So areas where this is already implemented is in shipping. So one of the largest shippers in the world, Maersk, has developed this together with IBM, and they use this for electronic bill of lading. It's used in agriculture and food. So there's a startup called BanQu, BANQU, which I definitely would encourage you to check out. But also large retailers like Walmart or food companies like Nestle are using blockchain actually to track, let's say, from farm to table a product. In the same way, it's also used, for instance, for batteries, and then specifically for the parts that go into batteries. So I work myself on a use case around the cobalt that is mined in Congo, and then shipped, it's mixed, etc., and then ends up in a battery in, for instance, your Tesla. So Tesla wants to make sure that their batteries are mined in, or that the batteries is mined in a responsible way, and the way to do that is to actually create a digital fingerprint of the cobalt, its origination. When did it come from, etc., and was it responsibly sourced? So supply chain is an important area.